In this presentation, we will compare the time complexities of deleting the last node of the single linked list and deleting the last element of the array. So let's get started. Here first we will find out the time complexity in case of deleting the last node of the single linked list. Here you can see this del last function will do the same job, that is deleting the last node of the single linked list. Here we are checking the condition, is head equal to null? We know that if head is equal to null, then our list is empty. So we will print this message, that is list is already empty. Otherwise, if head link is equal to null, this means that there is only one node in the list. So here in this case, we will just free the node and we will assign null to the head pointer. That's it. This piece of code will take constant amount of time. The main code lies in this else part. Here we have a while loop which is used to traverse the list. This particular while loop will take the most of the time. Here we are using this while loop to traverse the linked list until the end node is reached. If there are n nodes in the linked list, then the loop will run n times because we are moving towards end node, right? That is the last node of the list. If there are n nodes in the linked list, then definitely the loop will run n times. So the time complexity will be big O of n. Isn't that so? The rest of the piece of code will take constant amount of time, but this piece of code will take order of n time. So that is why the time complexity of this del last function is big O of n. Now here I am considering the code of deleting the last node of the element which we have seen in the last to last lecture, where we are considering two pointers instead of a single pointer. In the last lecture, we have seen how to delete the last node of the list by using just a single pointer. In that case, we are moving our pointer towards the second last node of the list and not the last node of the list. Obviously, the loop will run n-1 times instead of n times. Again, the time complexity remains same, that is big O of n. Now, what is the time complexity when we delete the last element of the array? Let us consider an array like this, which consists of these elements. Here we want to delete this last element. Here the size of this array is 8. That means we have 8 slots in this array and user has also entered 8 elements in this array. Okay, that is what I'm considering over here. We will use the size variable to keep track of the current active elements in the array. Okay, so size variable is used to keep track of the current active elements in the array. Here instead of deleting or removing this element, we will decrement the size variable by 1 so that we can simply ignore this element. So by using this particular line of code, we are creating an illusion that there are 7 elements in the array instead of 8 elements. So after decrement, size holds this value 7, which means that there are 7 elements currently in our array. That is the illusion we are creating, okay? So here is the piece of code which helps us in doing the same thing, that is deleting the last element of the array. Here we are decrementing the size variable by 1. You can see over here that size is initialized by size of ARR divided by size of ARR 0. That is, it is initialized by 8 because currently we have 8 elements in our array. After this, we will decrement the size by 1 so that we would be able to create an illusion that there are 7 elements in the array. And then after that, I'm using this for loop to print all the elements of this array up to this particular point. So 23, 3, 45, 12, 67, 54 and 6 will get printed. And this element will simply be ignored. So the output of this program is 23, 3, 45, 12, 67, 54 and 6. And the time complexity is definitely big O of 1, just constant amount of time. Please note that I'm not considering this for loop because this for loop is not part of deleting the last node of the array. We are using this loop for just printing the elements, okay? We are considering the time complexity for deleting the last element of the array. That is why the time complexity is big O of 1. In summary, deleting the last node of the linked list takes order of n time, while deleting the last element of the array takes constant amount of time. Okay friends, this is it for now. Thank you for watching this presentation.